Hey everyone, let's talk about problem number 1. So this is in terms of pi fourths. So I'm going to step around my circle here, and my unit circle, and I know over here I have pi, which would be 4 pi fourths, and over here I have 2 pi, which in terms of fourths would be 8 pi fourths. And that's going to help me because as I go around my circle, then I know I go 8 pi fourths, and then another would be 16 pi fourths, so I have to go an additional pi fourths, or 45 degrees. So over here I have the angle 17 pi fourths. Okay, so my reference angle now is going to be a 45-degree angle right in there, or pi fourths, and I know the ratio of the sides is a 1, 1, and a root 2. So I look at my signs in quadrant 1, everything is positive, and I'm ready to evaluate. The sign is opposite over hypotenuse, so I have 1 over root 2. Now the goal is to know that the sine of 45 degrees, or pi fourths, is 1 over root 2 without really thinking about it. You can rationalize if you want to. Okay, look at the next one, cosine of 5 pi. So I know this is 1 pi and 2 pi, and I keep going around. So 1 pi, 2 pi, 3 pi, 4 pi, 5 pi is quadrantal. I can't draw a triangle. So 2 ways to do this. One is to know the quadrantal picture, which says up at the top at pi halves, you have 0. 3 pi halves, down at the bottom you have 0, -1 to the left, and +1 to the right. If you know this picture, then you're done because you know that 5 pi points left, so your answer is going to be -1. Now, if you don't want to memorize a little trick, that's fine also. You could say, well, here on the unit circle is an ordered pair -1, 0, and cosine is always x over r. So you can see here that the x is -1, and on the unit circle, my radius is 1. -1 over 1 is -1. But again, the goal is to know that the cosine at pi is -1, and therefore you could quickly do 5 pi. Okay, tangent of 5 pi fourths. So I know that this is pi over here. That's 4 pi fourths. And over here, this would be 8 pi fourths. Okay, so as I step, I know that I would have to go into quadrant 3 here. My angle at 5 pi fourths is down here. Okay, so this is, again, a reference angle of 45 degrees, or pi fourths, and so I'm going to fill in my 1 and my 1 and my root 2, but at this point, I know that in quadrant 3, I have a negative x value, so it's really important. That's how this differs from problem number 1. This is also a negative y value. That doesn't really matter, though, because tangent, it does actually. Tangent is going to be opposite over adjacent, and -1 over -1 is +1. Now, the goal is to know that my reference angle is pi fourths, and so therefore you have memorized that the tangent of pi fourths is 1, and finally you would just say, but I'm in quadrant 3, and therefore in quadrant 3, a super trig class, everything in quadrant 3 for tangent is positive. Okay, as we go around here, 17 pi, let's do it. We got 2 pi, 4 pi, 6 pi, 8 pi. You guys get the idea? 10, 12, 14. Look how this pretty picture I'm drawing. 16, 17. Now, do you really have to do that? I am hoping not. I'm hoping you can just say, well, we're going to subtract multiples of 2 pi, and that will get us the same thing as just pi. So at that point, again, if you know your quadrantal picture, we got 1 up top, -1, 0, 0, and we know we're pointing to the left, so I know that my answer is going to be 0. Now, if you don't like those little tricks, I do not take offense to that. You would just say, okay, so right here, I have the ordered pair -1, 0, and sine is always y over r, so now I have 0 over 1, the radius is 1 in the unit circle, and 0 over 1 is 0. But again, the goal is to know without even thinking. The goal is to know that the sine at pi is always equal to 0 without thinking, and therefore we could really quickly do the sine of 17 pi. Okay, I'm getting there. I got 390 now, so we're going into degree mode here. We got one circle, which would be 360, so I have to go an additional 30 degrees. So now I need to know my ratio for my 30-degree triangle. 30, 60, 90 is 1, root 3, and 2. Okay, so everything's positive in quadrant 1, thankfully. They wanted the cotangent. I like to do the tangent, so I'm thinking that the tangent of 390, TOA, is opposite over adjacent, 1 over root 3, and therefore, when they want the cotangent, I can just reciprocate and say that the answer is going to be the square root of 3. All right, how do we do this one without thinking too much? Well, we want you to know that the tangent at 30 degrees is 1 over root 3. We want you to know that. And therefore, once you figure out that 390 has a reference angle of 30 degrees, all you have to do is reciprocate to get square root of 3. Okay, secant of 540. So, gosh, I got to go around. Let's do some mathematics. Here we go. Addition. I got to go around 360. Okay, so I'd have to go another 180. That will get me another quadrantal angle facing left. Now, secant is the reciprocal of cosine, and I know cosine looks like this, so all I have to do is reciprocate -1. If you think about doing that, -1 over 1, if you were to flip it, you still get -1. So my answer is indeed -1. And finally, we got 25 pi 6. So on this one, I'm going to say, well, over here is pi, so that's 6 pi 6, and this would be 12 pi 6. So as I go around, I'm going to go around 12 pi 6, then 24 pi 6, and I've got to go another pi 6, and a pi 6 is a 30-degree angle. So I'm going to say, all right, then this angle here is 30 degrees or pi 6. And therefore, I know the ratio of sides is a 1, a root 3, and a 2. And so they're asking me for secant. I usually don't think in terms of secant. I think in terms of cosine. Everything is positive other than quadrant 1, so that's nice. I don't have to think about that. Cosine is adjacent over hypotenuse. So I'm going to get for cosine root 3 over 2. Okay, again, the goal would be that you know without much thinking that a cosine of 30 degrees is root 3 over 2. That's going to be an eventual goal in this chapter as we practice. Okay, so we would know that this then is root 3 over 2 for cosine, but remember they wanted secant, so we have to reciprocate that to get 2 over root 3.